In this lesson, we're going to learn how to create a linear equation algebraically. We're going to write the equation in slope-intercept form. The first way is when we are given the y-intercept and a point. Then the second way, we're going to learn how to write it when we're given 2 points where one is not the y-intercept. To find or write a linear equation when we are given the slope and another point, the first thing we're going to do is we're going to find the slope between the point and the y-intercept point using the slope formula. So in your notes, please write down the slope formula. The slope formula is y2 minus y1 over x2 minus x1. Once you find the slope and then you identify the y-intercept, the value b, you can put it all together in slope-intercept form. So pretty much we're just filling in the value for m and the value for b. Before we try out the formula for slope, let's recall finding slope from a graph. Here we have a linear function and we have 3 points identified. We're going to see how many units it takes to get from this point to this point. Remember, slope is the change of the y's or the rise compared to the change of the x's, the run. So we're going to start with a point and move our way from left to right. So 1, 2, 3. So it's a 3-unit rise compared to a 2-unit run. So our slope for this line is 3 over 2. Now, let's take a look at these 2 points and just use the slope formula to find the slope between these 2 points. Remember, slope is a ratio and it can be expressed rise over run, the change of the y compared to the change of the x, or you could consider the vertical change compared to the horizontal change. So using our formula, -2, -2 is considered the first ordered pair that's given. Therefore, -2 is our first x-coordinate, so it's x1, and this -2 is going to be our y1, our first y value from our first coordinate. 0 is going to be x2, and this 1 is going to be y2. So the formula says, find the change from y2 to y1. So that's 1 minus -2, x2 minus x1. This gives us a rise of 3 and a run of 2, so 3 over 2. And notice -2, -2, and 0, 1 are these 2 points on this graph. So we have confirmed that our slope is 3 over 2. Now let's find the slope between these 2 points. This is x1, y1, x2, and y2. Slope, y2 minus y1, x2 minus x1. My rise is 6 and my run is 4. We always simplify fractions when we can, but when we're talking about slope, we do not want to convert this to mixed. We want to leave it as 3 over 2. So again, we can see that these 2 points, -2, -2, and 2, 4, are from the graph. So we could confirm that we're going up 3, 4, 5, 6 units, and then to the right, 1, 2, 3, 4, which does simplify to the 3 over 2. So once you find the slope between 2 points to write your equation, the next step is to identify the b value, which is the y-intercept. And you can see in our example, 0, 1, we have been given the y-intercept because it is when x is 0. So the b value is 1. Now we have m and the b, and we can write the equation. Y equals 3 over 2 times x plus 1. Now let's take a look at another example. First, let's make sure that we have our formulas. So our slope formula is y2 minus y1, excuse me, over x2 minus x1. And then our slope formula, or excuse me, slope intercept is y equals mx plus b. So this is the goal, is to write an equation in slope intercept form. We see the 2 points that are given, and the first thing that I do notice is that I have been given the b value, the y-intercept, because x is 0. So my b value is -5. Now let's find slope. We have y2 minus y1 over x2 minus x1. We have -7 over +3. So my slope is -7 over 3. My b value is -5. We can put this all together. Now, the next thing that I want to show you is that you can always check a point to see if a point lies on the line that you just created. So we're asking, is 3, -2 a point that goes through this line? So 3 is going to be our x value, and y is going to be 2. So we're just going to substitute y with 2 and x with 3 and see if we get a true or false statement. If it is true, then this point does indeed lie on the line. Oh, whoops, we need to substitute in. Remember, when you're substituting, I always like to use parentheses. So we've put in 3 for x, 2 for y, and now we are going to calculate here. So we're going to do the multiplication and then the subtraction. So we can see the 3's give us 1 times -7. And we have 2 equals -12. That is false. So we'll say no, this point does not lie on the line. Let's look at our next example. We want to find the equation in slope-intercept form that passes through 0, 4 and -2, 5. We notice that we have been given the b value, the y-intercept. So now let's find slope. This is x1, y1, x2, y2. So we have 5 minus 4, the change of the y's, over the change of the x's. So my slope is -1/2. The negative can be out front, it can be with the numerator or the denominator, but it all means our slope is negative. And now let's put the equation together. So this is our slope-intercept form. This is our linear equation. Now let's see if -6, 1 lies on this line. So this is our x value, this is our y value. Substitute y with 1, substitute x with -6, and calculate. A negative times a negative is positive, and 1/2 of 6 is 3. And we see that we get a false statement. So again, this point does not lie on this line. Now let's take a look at some examples when we have been given 2 points, but neither one is the y-intercept. So you can see in example 6, we need to first find the slope and we don't have the b value. So after we find slope, we are going to learn a new way to write a linear equation, and it is called point slope. So write this formula in your notes. This is called point slope because we are going to input the slope and we're going to input 1 point, and then we will be able to write our equation in slope-intercept form, which is the most useful form. So we're going to find slope. So y2 minus y1, x2 minus x1. This gives us 4 over 10, and that reduces to 2 over 5. So this is our slope. So we have the m part. Now we need 1 point to put in for the x1 and the y1. You can use either one of these points. I'm going to change to green so we don't get confused. You can go ahead and let this be your x1 and this your y1, but I'm going to use this point because it's all positives, and I like to use positives as much as possible. So our formula says y minus, I'm going to use this y right here, equals my slope of 2/5 that we just found, x minus the x value. And now let's simplify. We have y minus 1 equals, and now I'm just going to distribute. I have 2/5 times x and 2/5 minus -5. My 5's cancel, and I get -2. Let's keep going to get that y by itself. So then it's in slope-intercept form. I'm going to add 1, and we have y equals 2/5x minus 1. Here's the equation. Now let's check to see if 10(3) lies on this line. 10 is the x value and 3 is the y. Five divides into the 10, 2. 2 times 2 is 4, minus 1. We see we get a true statement. So yes, this point, 10, 3, lies on this line. Okay, let's do another example. So we do not have the y-intercept, so that tells me I need to use point-slope form. We're going to find our slope first. y2 minus y1, x2 minus x1. So our slope is -2. Now let's use point-slope formula. Let's change this to green. So I'm just going to use this first one since it's already labeled x1 and y1, and they both have a positive and a negative. But either point will give you the same answer in the end. So I'm going to have y minus y1 is equal to my slope of -2 times x minus my x value. This gives me really y plus 1 here. We're going to distribute this -2. Bring it up over here. Isolate the y. Here is our linear equation written in slope-intercept form. Let's check this out and to see if this ordered pair is part of this line. We're going to replace y with -1, x with -3, and calculate. This gives me a +6 plus 3, and no. So this point is not part of this equation. Okay, now you guys tried these problems.